Yeah. So tell me, what are your doubts? Yes. So could you find out? Okay. Just a minute. Let me see if someone else is here to join. Okay. Then I guess it is just you and I. Yeah. So the question in the last class was, why does the subordinate norm exist, right? So when I say why does this norm exist, it means you have to show that why does the maximum exist, right? Am I? What was the? Okay, let me just write. So this is it visible the screen? Oops. Matrix norm. Can you mute your mic? Subordinate to a vector norm. So what does it mean basically? Yeah. So first you fix. Now you unmute your mic and tell me. You first fix some norm, right? In Rn, am I correct? So this is a norm space, and then you define. Let us say this norm is, we are denoting it by norm subscript node. Okay, because this is just some fixed norm. I request all of you to please join on time, because otherwise I have to go back and forth. Okay. Yeah. So then you take any matrix. Let's take A to be A11, A12, A1n. Yeah. This is in MNR. Now if I ask you, what is the matrix norm subordinate to the matrix norm subordinate to, just a minute. Yeah. Is it visible screen? Yeah. So can you tell me what is this matrix norm subordinate to the vector norm? Here the vector norm is this fixed vector norm that we are taking. We're just denoting it by norm node. Okay, norm 0. So it is defined as maximum of norm a x by norm x such that mm, or maybe let us do one thing, remove this node here. Yeah, such that, okay, let me call it, just for the time being I'm calling it op. Okay, so this is all those, this maximum runs over all those x in Rn such that x is non-zero. Am I correct? So do you know, everyone is clear with this definition? At least the definition. Oh, okay. So in the last class I asked you this question. Why does this norm exist? Okay, let us go step by step. Step 1. If you take this a, if you take any x in Rn, then what can you say about a times x? What can you say about a times x? Will it be in Rn? The other, yes, it will be n cross 1 matrix. So basically element in Rn. Am I correct? And what about the other fellow who asked this question? Bishwa? So now you see that we have already considered a norm on Rn, which is this, right? So once we have a norm, I can talk of, and so norm x and norm ax, these are well defined. Am I correct? Because on Rn we have taken some arbitrary norm which we are denoting by this. Okay. So now that x belongs to Rn, so I can talk of norm x, and also ax belongs to Rn, then I can talk of norm ax. Am I correct? No, we are taking some arbitrary norm. Okay. That is one possible choice. That is one possible choice. It could be norm 1, it could be norm infinity. We are, norm is a function, right? So we are taking some arbitrary function, some norm. Okay? Yeah. Later on, maybe we will see what happens in the special cases. Okay? Now, step 2, you divide by this. Okay? Norm ax by norm x. Is this well defined? How? When you're dividing two number, see norm ax, where just tell me first of all, this norm x, is it a real number? And norm x is also a real number, so I should write these are well defined in R. They are real numbers, so you can divide two real numbers given the denominator is non-zero, right? So I want this norm x to be non-zero, correct? Am I correct? But when is norm non-zero? If and only if x is non-zero. This is the property of norm. X is 0 if and only if norm x is 0. We have seen this, right? You know the property of norm, correct? X is 0 if and only if norm x is 0. Am I correct? So, yes. No, no. Yeah, if norm is 0, yes, yes. So you can divide, right? So therefore, norm ax by norm x is well defined for every r, for every x which is in Rn times, oh sorry, Rn minus 0. Am I correct? Do all of you follow this? Yeah. So I can consider some set over this. What I do, I collect all these quantities. I can take all these quantities such that x belongs to Rn and x is a non-zero vector in Rn. Then this set is well-defined set, right? It is a well collection of well-defined real numbers, right? Am I correct? So what I am doing now, I am taking maximum of this set, or maybe let me put step by step so that when you see the notes, it should be clear. This is a well-defined. This is a well-defined set. Now, what you do after this? Now you take the maximum, okay? And this is your matrix norm subordinate to the vector norm. Am I correct by definition? Is it clear what I'm saying? This maximum that you have taken, it is precisely your, yes, subordinate to. So this is the matrix norm of A subordinate to the given vector norm. What is the given vector norm? Rn. On Rn, this is the, we have taken some arbitrary norm and fix it, right? Now the question is we are taking maximum over certain things. Am I correct? So the natural question that I asked in the last class, what should be the natural question? Why does the maximum exist? Correct? So this was your, exactly. It is not a finite set. If it has been a finite set, then obviously, yeah, yes. But then if it is a finite set, then why I should be believing that this maximum exists? So this was your question, and this was the question that was raised by the Vishwa. Now, can anyone answer me why does this should exist? Do you want to try now? Hello. Okay, I'll give you some hint and you try. Okay. The question is clear. Is the question clear first of all? Yes, 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 exactly. So you first compute AX. Now AX will be A11, A12, A1n, then A21, A22. A must be of this form, right? Yes, it is given to be a fixed square matrix. Okay. And your x must be of this form. Am I correct? X1, X2. Now, what do you get when you multiply the vector multiplication or the matrix multiplication? You will get A11 X1 plus, yes, yes, A11 X1, A12 X2, omuk omuk omuk, A1n Xn, right? First column. Then you similarly, yes. If you're learning a course of analysis, you should not be afraid of computation. That is the first rule. An1 x1. Let me just see if there are some other fellows to be. Okay. Now, can I write them as linear combination of x1 something here, which you will tell me, plus x2? This is easy to see, right? See, here you see everything is in x1, right? Next, you see everything here is in x2, or maybe a lighter color. No, this is too light. And here everything is in xn. So if I ask you what should be the first column here, it should be A11, A21, AN1. Am I correct? And here you will have, correct? But what are these? These are columns of A. Am I correct? This is the first column of A. This is first column of A. Correct? This is second column of A. And then this is last column, which is nth column of A. So, I can just simply write it as x1 v1, x2 v2, uh, xn vn, where A is nothing but these v1, v2, vn. Am I correct? This is the column, so I can write it this way. Yeah. Now you apply norm of Ax. It should be norm of x1 v1 plus norm of x2 v2 plus this thing, right? Because this is nothing but Ax. Am I correct? Now can you apply triangle inequality here? Norm follows triangle inequality, right? So it will be norm x1 v1 plus norm x2 v2 up to norm xn vn. Am I correct? Yes or no? All of you know triangle inequality. Last time we discussed. You apply triangle inequality n times. What is triangle inequality? Norm of a plus b should be less than norm a plus norm b. And this is what we are applying n times, correct? Yeah. Now x1 is a scalar, am I correct? x1 is a scalar. x1 is a real number. See? So, and v1 is a vector. Remember that x1 up to xn, they are in R as number. And v1, v2, vn, they are in Rn. Am I correct? Each x1 is a real number, x2 is a real number, xn is a real number. But v1, v2, vn, they are vectors. They are columns of a, so they are vectors, correct? So you know this property, norm of alpha v, it should be mod alpha times norm v. Am I correct? This also we have seen. So use this property here. It will be, can anyone tell me, mod x1 times norm v1, right? Plus mod x2, yes, very good, times norm v1, yes. Now what you do, define, you see each x1 will be smaller than its infinity norm, correct? You remember infinity norm? What is infinity norm? Last time we did it. Maximum of, yes, maximum of modulus, right? So x1 will be smaller than this, and as rest of it as it is, correct? Less than equal to I have written. Then x infinity. Then is this step clear, Bishwa? Is it clear to you also? Now can you take norm x infinity common? Or maybe, because we need something, let's not do this. mm, yeah, okay, let me tell you one thing. Okay, okay, yeah, this won't help. I mean, this can also help. mm, okay, you take alpha to be maximum of norm v1, norm v2. So this maximum will exist, right? Because this is the finite number, maximum over finite number, correct? Did I confuse you? See what we are doing here. This is a real number. This is again a real number. This is again a real number, right? So we are just taking maximum of this. Am I audible? Yes. Yes. So I can just take then alpha common and I can write mod x1, mod x2. Correct? Or maybe if you are so rigid, then maybe alpha naught. Okay. And this is independent of x. Am I correct? This alpha naught is independent of x. Yeah. Up until now, is there any doubt? They are columns of A, na? So once you know A, see, we want to. we want to compute the norm of A, the matrix norm of A subordinate to the given vector norm. So in that sense, only A is fixed. You know A11, you know A12, blah blah blah. All those Aij's you know. So basically, you can compute this alpha naught from the given data, right? Because V1 is a column of A, V2 is a column of A, Vn is a column of A. Now, yes, and it has to be. It is good that we don't have any connection. Okay? Okay. Now, what is this? What is this? This is nothing but alpha naught norm x, the one norm of x. Am I correct? Am I correct? You were there in the last class? Oh, okay. Then, the norm. Oh. So, norm x1 is a function which just you add the entities of x. Okay? Yes, and this gives you a norm. Okay? Yeah. Now, in the last class, we saw if there you will only study three norms here, so let us just restrict ourselves to this. If you have, then there was two norm also defined. It was mod xi square, then you take add them up and take the square root. Okay? And last was the infinity norm. Yes, I varying from 1 to n. Okay. In the last class we saw that all these norms are equivalent, right? Bishwa, we saw that. Yeah. So no, no, I am telling you. Uh, okay, let me just recall two norms. If you take two norms on a, like on Rn, if there are two norms, let us say one norm is this. Uh, this is your some norm, and then again you can have more than one norm, right, on a same space, and say this is your different norm. Then let's say n. This new norm and old norm, we say they are equivalent if there exists m1 and m2 strictly greater than 0, such that you know norm x, this old norm, is less than new norm is less than equal to m2 times. Okay, basically these two norm bounds each other. Okay, or another way to see this is the following, that this is less than 1 by m1 times xn, and this is less than greater than equal to 1 by m2 norm xn. Is this clear? Basically, you, and this holds for all x, such that for all x in Rn. This is important. This is important. Is the definition clear? Mm-hmm. 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 No, no, these are just some notation. They are two arbitrary norm. Okay, maybe yes, 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 yes. Okay. Any, for example, you when we talk of two function, how do you denote it? F1 and F2, right? Any arbitrary function F1, F2, or G1, G2. So here I have denoted it by norm n, norm 0. Okay. Now in the last class, please. Yes, yes. In this course, yes. In this course, I am sticking to these three norms. Okay. Now, Bishwa, do you remember the last class? Bishwa Jyoti, do you remember the last class? We saw there that these three norms are equivalent, right? Yeah. Yes. Biswajit, what we proved in the last class, I will write result. This we proved actually. Number one, the two norm is actually less than equal to root n times infinity, greater than equal to x infinity. Second thing we proved that infinity norm is less than equal to norm x1, which in turn is less than equal to n times norm x infinity. And third, using these two, we proved that norm x2 is, or yeah, n root n, sorry, yeah, we proved these three. So what does first say? And this holds for all x in Rn. Okay, these three holds for all x in Rn. Now, what does it say? What does the first result say? It says that two norm and infinity norm are equivalent, right? Am I correct? Biswajit, am I correct? Yes. Basically, you don't go to the definition, you first feel it. What does equivalent mean? That whenever you have, like, okay, let me just explain very quickly because you didn't, there can be two norms, right, on the same space. Let's say this is, maybe if you're confused, let's say norm and norm star. Okay. These are two different norms. To give you some example, in Rn, when you go to R, what is, you can define this norm mod x, right? This is the norm. Do you know what norm is? This is one example of norm. Okay, I think you know what a norm is. Yes, it is a one kind of distance, and it is, in fact, norm is a function from Rn to R such that norm x is always positive. Second, norm x is 0 if and only if x is 0. Norm is not a notion of distance, more like it is a length function. Okay, think of it as a length. Now, length should always be greater than equal to 0, right? Length of something. Second, length should be 0 if and only if you are measuring nothing. Correct. Third is, if you're, if you're stretching, then this stretching should be this. Length of 2x should be 2 times length of x. Am I correct? And fourth is, length of x plus y, it should be plus length of y. This is a norm. Whenever a function satisfies these property, we call it a norm. Okay, mod x satisfy all these properties. But there can be another norm. But for example, you can, let us say star. You can define it to be mod x by 2. This will also satisfy uh, all these four properties, all the conditions. So on one space, there can be two different norms. Am I correct? By who told? What is mod x? Mod x is nothing but if you're taking x. So it is just the distance from 0 to x, which means the length of x. Am I correct? What does mod x give you? Mod x give you distance of 0 to x. So who told you it should be just mod x? Like it could be mod x by 2, right? I am not saying 0 to 1 का जो distance है it is 1 for me. I am saying I live in some another world and here the distance is half. It could be a possibility, right? So on the same space there can be more than one norm. So then it would become difficult how to compare, right? Then there should be a parameter of comparison. Am I correct? Two things should be if there are two notion of length, I would want them to be comparable to each other. You should ask because it is not clear. It is not my duty to answer as well as find questions for you. You should ask. So first thing is there are two notions of distances here at present, mod x and mod x by 2. Now what what should be the natural question? Ki, are these two distances equal? First of all, are these two equal? The answer is no. Clearly the answer is no. The next question could be, okay, they are not equal, but can I compare each other? In the sense, if I have, let's say, the norm x, can I get some estimate for norm x star? Then also it would be a good thing, right? For example, if I know, all I want to say, if I know norm x, can I know, is there some way to know norm x star? Do you get my point? So yes, is it possible to know? So what is the good way? If I can bound norm x star in some, you know, both side by some multiple of norm x, which is given. Am I correct? No, they are not scalar multiple of each other. Here it is, but in general it might not be. Okay, but can be bound. So this is a norm. This at present, what I'm saying, this is known. This is a given thing, right? Because I'm starting with this too. I'm starting that norm x I know. Now I want to gather some information about norm x star. So this is a natural thing, right? In the sense that, okay, if I know norm x, let's say if norm x is, and this m1 m2 is also known to us, then if norm x is, let's say, let us say this satisfies this inequality for the time being, 5x, and let's say half norm x. Then if norm x is 1, Then what can you say about norm x star? It will be between 5 and half. Am I correct? So in this way we know something about norm x star. We might not know the exact value, but we know some estimate, and that is also a good thing, right? We know some bound, and that is where the notion of equivalent norm comes into the picture. What does equivalent norm says? Now you look at the definition again. It says once you know, once you have some information about first norm, you can actually bound the second norm. Yeah. So now, yes, exactly, exactly. Now you see the first result. What does it say? It says if you know the infinity norm, yes, and the other way is also true from one only, right? Now what about the second norm? A second result. It says if you know something about norm one, then you can, yes, and same goes for the third also. Okay. Yeah. So this is the, now you know why do we call it equivalence? Because it gives you uh, some sort of information, yes, some sort of very vital information rather, I would say. And if you have learned topology, have you learned topology? I guess no. Okay, then I will not go there. Yeah. Now you see, if so, here we were stuck, right? This is the place where we were at. Let us make it star. As I'm saying, because we will be dealing with only three norms in this course mainly, and what does star says? By star, norm ax is alpha naught times norm x1. Am I correct? And this is holding for all n. Correct? And this alpha naught was independent of x. This we have proved. Independent of x. Now you see, since we'll be interested in, we'll be interested in the case when Rn, we started with with one arbitrary norm, right? Is either the first norm, or has either norm 1 or norm 2 or norm 3, or norm infinity, sorry. So in either case, in either case there is some capital M independent of x, independent of x, this is important, independent of x, such that, such that norm x1 is less than equal to m times norm x. Is it clear? For all x in Rn. Oh, this is less than equal to. Yeah. Is it clear? Hello? Capital M. You see, what I'm saying is, see, if you look closely, we wanted estimate for this. You wanted estimate for this. Norm AX by norm X. Am I correct? When R, so we fix one norm, but what we are getting norm X upon norm X naught, norm X1, right? From here, we are getting that this is less than equal to alpha naught. Am I correct? But we want in the denominator norm X, the norm we started with. So what I, instead of norm X1. But because in this course we'll be dealing with either norm 1, norm 2 or norm infinity, so I can always compare norm 1 to this given norm, right? If let's say this given norm is 1, then m is has to be 1. M can be 1, right? There are so many. Uh, for example, if this norm is same as norm 1, then choose m to be 1, correct? You can choose m to be 1. Now, what about if this given norm is norm 2? Then by third, you see, by third, what can you choose? You can choose your capital M to be n, right? Why are you so confused? Should I go slow? Okay. Okay, tell me, where is the confusion? Maybe I'll start again, in the sense I'll give you. So we want to compute a matrix norm. So first you start with Rn and you fix this norm. I don't know what this norm is. You fix this norm, okay? This is now fixed. It could be norm 1 or norm 2 or norm infinity. Out of these three norm, it could be anything. Now I want to compute this norm, which was nothing but norm AX by norm X when X is non-zero. Correct? This is correct? Yes, this is the definition of a matrix norm subordinate to this given norm. Okay. Now my question was, why does this exist? So if I show that this is bounded by some given number, this is bounded by some given number, let's say beta, for all x, then I am done. Yes. So this is what I'm trying. Yes, because R has completeness property. Okay. Now this is what I have to show. But what I have been able to show so far is that this norm x1 is less than equal to alpha naught for all x. This is I have shown, right? And this beta has to be independent of x. But alpha is also independent of x. So where is the problem? Can anyone tell me where is the problem? Yes. 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 Exactly. So there are only three possibilities, right? Three possibilities when this norm is norm one, correct? Then I am done in this case. Now what about if norm is norm two? Then what do I have to show in this case? I have to show that norm AX is norm x2 is less than beta, correct? For all x non-zero. This is I have to show, correct? Because I am choosing my norm to be 2 norm. What I have proved here is, but can anyone tell me what I have proved? I have proved in this case that norm x2, norm of 2 norm of x is less than, yeah, this I have proved, right? Because I am taking this same. These two norm are same. So the numerator will replaced by 2 norm. Yeah. Bishwa, is it clear to you? Yes. Yes. Now we know norm x1 was greater than equal to. Can I use this property? Norm x1 is greater than equal to root n 1 by root n times norm x2. Correct. So what does it imply? That norm x2 by norm x1 will be less than equal to numerator as it is, then this times root n. Am I correct? Yes. Or have I done something wrong? Or maybe make it simple. Okay. I have proved this. Now use the inequality equivalence relation. This relation you use. Norm x1 is less than equal to n times norm x2. Correct? Now you take, norm x2 in the back in the denominator, and you will get this will be n times alpha naught. Am I correct? For all x non-zero. And this is your beta, right? Because it is both are independent of x. And I am done. Correct? This is what I had to prove. And same thing goes for infinity norm also. So all I'm saying is, in either of the case, it doesn't matter what your given norm is. You can always bound norm 1 by, you can always have this relation. I just proved it for you. Yes or no? So therefore norm ax, which I have proved to be less than equal to alpha naught times norm x 1, it can be further less than equal to alpha naught times norm x for all x in Rn. And this bound, this is actually independent of independent of x. Am I correct? Why this is important, we will see. So therefore, for every x which is non-zero in Rn, we have we have norm ax by norm x is less than equal to m times alpha naught. Am I correct? So this supremum will also be less than equal to this. Am I correct? Or in fact, maximum you can take. Maximum, right? X non-zero. But what was this? What is the left hand side? This is the matrix norm. Am I correct? And so this is a finite number. Now is the proof clear? Why does this norm exist? If you have doubt, please ask. Okay. Otherwise, I will give you now questions. Is it clear? Okay. Okay. Then I am writing some question and you prove it. Okay. Just give me some time. Okay. Maybe I will delete this page. So first you have to prove that. Prove that. You know, uh, if I define A for A in Rn, sorry, the question. So write down the question. So let given. So first I am taking the infinity norm. Okay. So this norm and A in Rn, A in the n cross n matrix, define or find, maybe find the, is the question clear? Is the question clear? So what is this? This is the matrix norm of A subordinated to which norm? Yes, subordinated to infinity norm. Yes. Yeah, please find it. You first find norm AX. If A is, we know what is norm AX, right? If A is, I will just give you hint and then I will leave this question for you to give me a solution. Uh, why do you want to view the previous pages? Okay, then you just tell me. Okay, I will scroll up and down. We have proved that this is nothing but summation. Let us not write down in the form of summation. A11 x1 up to a1 n xn, correct? A21 x1, so on and so forth. An1 x1. Yes. So ax is your vector, right? As you can see, it is a vector, and its general entries of the form aij xi, aij xj, where J varies from 1 to n. This is a column vector. So what will be norm Ax infinity? Because you need it in the definition. Am I correct? Now you do. Take your time. So what is Ax infinity norm? Hmm. Mm-hmm. Just a minute. First of all, let us go step by step. It should be maximum of modulus of this, right? Yeah, which is just this. Am I correct? And I varying from 1 to n. Correct? Now, can you see some triangle inequality thing here? At least in this one. So this will be less than equal to summation. So I can say this. Am I correct? And the maximum will remain. Yes. Now each of this mod xj is less than equal to its infinity norm, right? By very definition. Outside. Very good. And this is what remains is the maximum of mod a, j varying from 1 to n, and I varying from 1 to n. Am I correct? Now you see this holds for all x, right? So in particular, when x is non-zero, uh, this will happen, right? This will be less than equal to maximum of. Am I correct? Hmm? Now, can I run? Oh, yeah, this was infinity norm. So can I run the supremum now? Because this holds for all x non-zero, right? So this implies norm a, which is maximum over x non-zero of ax this by this. So this should be less than equal to, because everything is less than this big number, so maximum also has to be less than this number, right? Bishwajyoti, is it clear to you? Yeah. Now what is this? Can anyone express? Oh, sorry. What is this? This is called. Yes. Tell me, please. Yes. It is absolute row sum. Am I correct? Yes. The summation quantity is basically, I'm just saying what is in the bracket. Okay. So this is the absolute row sum. Absolute means you're taking modulus of each component and then you're adding. Okay. So this gives you that norm A is less than equal to maximum I going from 1 to n. So is it fine up until now? So my question is, but still it is an inequality, right? If I show, if I show that for some, uh, okay, can they be equal? Can they be equal? This is my question. Do you get my point? What I'm saying? Yes, yes. Are they equal? In fact, they will be equal. This is the claim. Claim is, yeah. Claim is that they are equal. Less than equal to I have already proved, right? Less than equal to we have already proved. Now I am giving. If I prove that for some x this is attained, then I'm done. If I show that this maximum is attained at one point, then I'm done. Correct? Okay, okay. Let me just ask you to compute one thing. Okay, you know signum function. Do you know this function? When x is positive, it takes 1. When x is 0, this is 0. And when x is negative, it takes 1. This is called sine function. Okay? Everyone knows this function? Yeah. So then can anyone tell me what will be x sine x? Hmm? So tell me what is this function? Is that a familiar function? Is it not? Yes. So this is a familiar function, right? Yeah. So this is one thing. Second is, see, you're computing maximum over this thing, right? And these are finite number. Am I correct? What I'm saying is we are computing maximum of finite number. So this is absolute row sum. Then I going from 1 to maximum will be attained at some point, right? So let us say maximum is attained at k. Okay. Yes. So we are taking absolute row sum, right? Let us say absolute kth row sum is the maximum. Okay. Now I am giving you one vector. You tell me what to do. Okay. Now define x to be. So x will be of this form, right? Any x. It will be x1, x2, xn. So now we know that this. Just a minute. Now let x1 be sine of ak1. Okay. X2 be sine of ak2. Then this is sine of akn. Do you get this function? What is x1? X1 is the sine of, yes, ak1 entry, and which means first entry of kth row. Yes, वही तो कह रहा हूँ. Yeah. Now tell me what is x norm? Can anyone tell me what is x norm? What is infinity norm of x? Yes. Maximum of akj, where j is varying from 1 to n, and it will be 1, right? Because sine function is either -1, 0, or 1. If it is -1 and 1, then modulus should be 1. And if it is 0, if maximum is 0, which means sine is 0, which means each entry in the x is 0. Am I correct? What does it mean? That x is a 0 vector. But if x is a 0 vector, it means this summation mod akj, it is 0. But this is not possible, right? Yes. No, we have defined this way. If if norm x infinity is 0, then this implies x is 0. Then this implies sine of akj is 0 for all j. But when is sine of something is 0? When the number itself is 0, right? Yes. And it will imply that summation mod akj is 0. Am I correct? but we know by one, we know by this, because we have taken it to be maximum. Let us put it to be exactly. This is what I'm trying to say, that if you start with non-zero matrix, yeah, you make it non-zero. Okay, exactly. So this has to be non-zero. So if you follow this, eventually it will imply a is zero, right? And this is a contradiction because we are starting with a non-zero matrix. So one thing we know, that the infinity norm of x is 1. Now compute the infinity norm of ax quickly. I have given you, okay, maybe if I uh, make it vertical, then it will be easier, right? Is it fine now somehow? What do you have to compute? The infinity norm of ax. Please compute and tell me. Do the computation. So what is it? You can take off the previous computation. Like we already know what is ax. We proved here that uh, norm x infinity will be this. Am I correct? Yeah. Now tell me what to do with this. Yes. So can you see one thing in this, that it takes a lot of hard work to do all this conceptual thing. So I would like you to ask as many questions as possible. Okay, when I is k, you know, so first entry will be, like summation. We are running maximum over I, so we are actually running maximum of some things, right? Some finitely many things. So first thing will be mod a1j xj, correct? This mod. Yes. Then you keep on doing this, you will hit the kth row. Am I correct? And then you further move, you will go to the last thing, which is anj xj, j going from 1 to n. Am I correct? Now you look at this particular one. What is akj xj? How is xj defined? Xj is defined as sine of akj. Am I correct? So this is akj sine of akj. And can anyone tell me what it should be? It is nothing but summation mod akj, right? Is it clear? Yeah. Yes, and we proved this, right? We saw this. X sin x is mod x. So same here, akj, and you are multiplying with its sign, so it has to be modulus, right? Yeah. And what is this? This is the maximum row sum, right? Yeah. So one is this, and but if everything. Yes, but we have also proved that each of this will be less than this number, right? Norm ax infinity, what we have proved? But we know that norm ax infinity is less than equal to, tell me, norm x infinity times maximum of absolute row sum. Am I correct? This is, let's say this is a. So but what is absolute row sum? What is absolute row sum? It is the kth row sum. Am I correct? This we assumed. And norm x infinity, we know it is equal to 1. We proved this. So this is one thing. Now you tell me, when we were computing norm x infinity, one of the member is summation mod akj, correct? But norm x infinity is also less than equal to summation mod akj. So they has to be equal, right? Upper bound is there in the set over which maximum is taken. You see, this is an upper bound, right? But this upper bound is already there in the maximum. So they has to be equal, right? Think logically. This is maximum over some finite number. Am I correct? Maximum over some number. And one of the number bounds every other number and it is already in the set. So this has to be the maximum. No, don't say yes, sir. If you are not, then I will prove. Okay, there is an easier way to, yes. So there is an easier way. All of us agree that this is less than equal to summation mod akj. Am I correct? This is the second thing, right? This we have proved by this. This all of you agree? Do all of you agree with this? Norm ax infinity is less than equal to absolute kth row sum. All of you agree? Yes or no? Yes. But you see, what is norm ax infinity? It is the maximum over some number, right? So maximum has to be greater than equal to each element in the set. But one of the element in the set is summation mod akj. Am I correct? So they have to be equal now. Yes. So what you have proved is that, so ultimately what you have proved. So here, yes, kth rows. So first we have this inequality, right? We have this inequality here. We wanted to prove an equality. So what did we prove? That this maximum is attained at the kth row. Am I correct? So they have to be equal now. Okay. So hence norm A is nothing but the maximum of the absolute row sum. So you see, all these proofs seems easy, but it needs some investigation. Am I correct? Here, this is maximum norm x infinity. Yeah. Now, I am writing a matrix. You find its subordinate norm, matrix norm subordinate to infinity norm. Okay, and it's easy. Yeah, just find 1, 2, 3, maybe 0, 0, 5, minus 1, 2, minus 3, 0, 0, 1, 0, 4, 0, 6. So can anyone tell me, please tell me this, the matrix norm subordinate to the Infinity norm. This is 10. It is easy to see, right? Why the first row? Am I correct? Yeah. Mhm. N is the maximum. Oh, yes, that is correct. That is indeed correct. Mm, yeah. So up until now, if you have some doubt, please ask. I am then uh, moving forward with something that I have in mind. Yes. Mm, difficult. Yes. Yes. This is why these tutorial sessions are held. Like in your regular classes, you will find that numerical techniques are being taught. Okay. But what I have the instructions for to clear these conceptual part. Do you get my point? Because see, if these proofs are left, then you will not get to see their proofs. You will not get to learn the techniques that are involved here. Anyone can remember what is this norm subordinate to infinity norm, right? It is not difficult to remember. This is very easy. You even told me the norm before writing the full question. Yes, exactly. This is even a class fifth student can tell what is this. If I tell him, you add up the row, the absolute sum, and he will tell me what is the maximum. But what as math students we should learn how these two entities are equal, and this is precisely what we saw. Am I correct? All this drama, all this jargon was to just to make sure that this infinity norm is nothing but the maximum of the absolute row sum. Now you can ask the similar question for the one norm. So can you do that? Do you get my point? Yeah, now try that. Or at least give me some bound. I want for you. So this time I am taking Biswa Jyoti. Is it clear to you? Yeah. Now you proceed as we proceeded in the. Okay, let me open the proof of the previous question, because question you already know. Maybe you follow this step and you will have some bound. Okay, at least tell me an upper bound. Take your time and tell me the upper bound. It is very easy. Like just do the computation. Question is okay. You write down the question. This is the question. Now, whatever business we did with the infinity norm, I am asking you to do it for the one norm. One norm, right? You add the sum. Like norm x1 is nothing but mod x1 plus mod x2. Okay, is it clear? Yeah. So if this question is clear, I am going up so that you can see the previous proof. Can I go up? Is the question clear? You people don't say anything, yes or no. I mean, how would I know that this is okay or not? That is what I'm asking. Is the question clear? Now, if you have written the question, I am moving to the proof of the previous question. You please follow the proof step by step. Okay, and make some adjustment because the norm is changed. So are you following something out of it? Okay. Okay. Yeah. So tell me. Mm-hmm. 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 Okay, let us see what you are saying. So I am just copying. No. Yeah. Sorry. So this will be my AX, right? AX will be this. All of you agree? Then what is norm AX1? Now we know one norm. It is you add each entry, right? So this is all entries. So first is summation j over 1, and then you have to add over all I. Am I correct? Yeah. So if you use triangle inequality, so here sum is running over I, then you will get sum is running over j, then mod ij xj. Am I correct? You know finite sum can be interchanged, right? So this is summation j, summation I, then mod ij, mod xj. Am I correct? No. Yes, you can do that, or directly, you see this also. Yes, yes, you can go wherever you want. Okay, ultimately we need to find something. Okay, you see what happens in that approach. Now you see, when you have this j is independent of I, so I can throw it out, right? Here, the sum runs over I. Am I correct? So I can throw this xj out of the bracket. Am I correct? So in the bracket, you will have mod aij, I going from 1 to n. Correct? Now what is this? This is absolute column sum, right? Just take a minute and realize this. Yes. So it will be less than equal to its maximum, right? So this thing as it is, and it will be less than equal to maximum of summation. If I take maximum, then obviously this will be less than, right? I am taking maximum over the column sum. Do you get my point? Huh? Abhi you will be realizing. Just wait, okay? Now let this entry be for a while because otherwise I have to write it again and again. So this is a column sum, so I am denoting it by, let's say, C. Okay? Is it fine if I denote it by C? Maximum 1. What is maximum 1? Yeah. So so it is nothing but just C times mod xj. Am I correct? But what is this? This is C times 1 norm of x. So what does this give? That 1 norm of x is less than equal to C times. Now you know why we took maximum, because I want to have the columns 1 norm of x, and this holds for every x in Rn. So what does it imply? That this norm, which was maximum of norm x1 by norm x1 x non-zero, it will be less than equal to C, right? But what was C? It was the maximum of absolute column sum. Do you get my point? Now, in fact, one can prove that, you prove that, okay? Exercise. That they are equal. Exercise. Maximum of this matrix norm subordinate to this is actually the maximum of. Isn't it interesting that for infinity norm you are getting maximum of row sum? Now here you are getting maximum of column sum. What is this? This is absolute column sum. Is this clear? No, please repeat. Then you will have n times maximum value, no? You are saying here at this step, right? Hmm. because this is a column sum. You realize the in the pink circle you have absolute column sum. Hmm. So it will be always less than equal to its maximum. See, what is the pink circle? The entity in the pink ellipse is the I absolute jth column sum. Am I correct? This is absolute jth column sum. So, no, I am just using maximum property. So this is jth column sum. Okay. So it has to be less than equal to it's the maximum of all the absolute. Hello? Yeah. There are n columns, right? So every jth column sum will be less than or equal to the maximum of all the column sum by definition of the maximum. Yes, I can always do that, right? Yes, exactly. Exactly. Maybe if you're confused, so you just see this part only first. Okay. This is less than equal to. Okay. For each column, it should happen. Now, I'm taking maximum over each column, right? So, yes, yes, that is written over there. That sum j going from 1 to n mod xj. Okay. Yes, 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 yes. And now this maximum is independent of j, right? Uh, so you can, which is why we can denote it by some fixed number c, and this c can come out because it is independent of j now. The sum is running over j. Now, what you do in your home, you can think of question. This part is not easy. You can think of maximum of now the two norm. Okay. Yes. 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 For infinity, we know it is maximum of absolute row sum. For one, we know it is absolute column sum maximum. Now, what should we have for the norm two? And while we are here, can anyone tell me the this matrix norm with respect to the one norm? What it should be? The matrix norm subordinate to the one norm. But it should be yes, the fourth column, right? Okay. Okay then. See you next time. Yes.